This is a walkthrough of the Mixpeek Bright Data integration. So if you are, for example, a NeoLab or a customer support company, and you want to pull in data from the internet, be it LinkedIn, web scraping from Crunchbase, or whatever, YouTube, then you're going to want to pay attention to this demo video. In it, we'll walk through using Bright Data as the synchronization connection, funneling the data from Bright Data in a continuous way into a Mixpeek bucket, and then processing it, pulling out metadata, pulling out embeddings, pulling out everything that you would need in order to create rich labeled data set for downstream processing. If you're training models, building an application, etc., this is what you'll want to pay attention to. All right, so in the Mixpeek Studio, what we can do is go into our settings, go into connections, and as you can see, I have a bunch of connections here. One connection that you can create here is the Bright Data connection. And so we would give it a connection name, the API token, potential customer ID, etc. And so this is just your specific configuration on the Bright Data side, so that when you create a synchronization job, you're actually selecting this connection and configuring the per sync parameters. So for example, the dataset ID, the URL you want to use, the batch size, etc. So we actually already have the sync created here. Let's go into the bucket that is being used for that connection job. So as we can see, we have this one bucket called Bright Data Scrapes. It has a particular bucket schema. So the schema is really just the data structure that we'll be using to ingest data from Bright Data. It's important that we define this up front because then we can pass in these values into the feature extractors down the line. So we have the Bright Data bucket. We have the synchronization connection already created. I've paused it for now, but as we can see, we have it polling every 5 minutes. So it's just running the Bright Data sync job every 5 minutes. And what's really nice here is we're actually automatically able to do the uncover what the deltas are in between every scrape so that there are no duplicates. So that's what this skip duplicates capability is. So we have a batch size, we have max object run size, etc. And so as we can see, we have objects that have been ingested. In this case, it's just text. And we are processing it through a decomposition pipeline, right? And in Mixpeek, you are decomposing objects. So these are the raw payloads. They could be videos, they could be images, they could be text, documents, whatever, from Bright Data, in this case, the bucket connection source, processing it through a collection. In this case, it is using this text extractor, I believe it is. It's using this text extractor, and this text extractor uses this feature extractor set of configurations. So in this case, it's really just embedding the text using the multilingual E5 large instruct model. But it can be any number of feature extractors that you can use. Just to show you some of the collections that we've used in this example, we have, let's see, article, this is a clustering job. Let's go back. Oops. No. Oh, we're using the wrong namespace here. Yeah, so let's use the Bright Data Intelligence namespace, and let's look at the NeoLabel embeddings. So I believe these are probably just embeddings. So we've embedded label, text, etc., and it's using text extractor v1 embedding, and that's the only one. So we have a bunch of labels, we have a bunch of text. These are what was pulled out from the scraping job. So we have Bright Data Scrapes that has 843 objects, and we have 2 other buckets here. I think these are just reference data sets that we used for the taxonomy down the line. So we have our collections that were the outputs of the buckets after we've done the processing using feature extractors. Let's see, this one's also a text extractor. But we have the collections here, right? And so then what we can do is look at our retrievers, and our retrievers are multi-stage retrieval pipelines. In this case, it's only doing an article search execution that is feature search. And in this case, actually, let's look at the stages. It's using just the feature extractor feature URI. So this is how we do feature search. We can combine this stage with other stages. We can use these retriever pipelines for classification. So in this case, this neotopic classifier, the output is taking the results from this collection, and it's using reciprocal rank fusion in order to return the top end documents. Right, and so if we get into the labeling component, we would use the taxonomies capability in order to actually label the output of the retrieval join operation. And so let's use this neotopic taxonomy v3. We could say we have our source collection, and that in this case is those class IDs and labels. So these are what you provide manually, not what the bright data scraping provides, but more of a reference data set. And we use the retriever that we've already created in order to find the most similar labels based off of the web data that was scraped using the bright data scraper. So this gives us the ability of just doing basic semantic search matching, say, hey, given the bright data web data that we're scraping, we should actually find the most similar label from the source collection, from the reference collection that we have. And so what we can do is look at the output collection. So it materializes it, which means it saves the enriched labels in a new collection called web articles here. Let's take a look. And we can see the joined collection, or the joined fields. So we have a bunch of data that was pulled out using the web scraper. Let's take a look here. There should be a label here. Oh, nice. Okay, so we actually got an enrichment error, but we can troubleshoot that later. But the point is that we can use the retriever that we've created in order to do a join between a reference collection that we already have as the source of truth, right? The labels, the IDs, etc., and the newly scraped bright data, scraped articles, in order to do that matching automatically as the bright data scraped website data comes in. And so as you can imagine, we can use this for videos, we can do this for images, audio, documents, etc. And it doesn't really matter if it's text because we can use different feature extractors for those different modalities. And so we have a bunch of feature extractors that are available out of the box here. So we've got the multimodal extractor if you're using videos, right? So if we want to pull up the transcriptions, we want to generate thumbnails, we want to generate descriptions, response JSON outputs, labels, etc. We would use this, and then instead of the text extractor, we would use the multimodal extractor. That way we can do a join based off of a reference data set. Maybe it's sample images, maybe it's sample videos, or maybe it's tags to automatically find what is most similar from the bright data scraped web data. And so you can see we are treating bright data as a very important source for our downstream use cases, because this gives us the ability of just pulling any raw unstructured data from the web via, if it's news articles, if it's videos, if it's files, process them through the object decomposition flow, use retrievers to find the most similar labels, and then enrich them all using taxonomies. And so this gives us the ability of maintaining the hierarchical labels so that we can have a rich, newly configured data set that actually understands our reference data set against the raw unstructured data set. And so that is the walkthrough of using bright data as a source for our buckets in order to actually do the decomposition, and then ultimately rich labeling, which can be useful for fine-tuning models, useful for building applications, useful for recommendation systems, search, etc. Thank you.